Good morning, class. So, today's lesson, lesson 9, we will be exploring the solutions for linear equations. Okay, so to give a brief overview of what I mean, um, we've been solving linear equations and finding the missing variable, okay, the value of the variable. Those type of linear equations that we were solving only have that one solution, as in that one answer we found is the only answer that will make the solution work, where the value or side A is equal to side B. Okay. So now we're gonna look into like more specific details of how we can identify if an equation has one solution or more than one solution or maybe even no solution. Okay, we're going to focus on one and more than one in this lesson, and we'll talk about no on Monday. Okay, so to start the lesson off, let's go ahead and read the directions. Okay, remember, bringing back this habit, we're boxing our verbs and we're underlining our action that the verb is telling us to do, or that our verb is referring to. I'm sorry. So it says complete each step with your partner. All right, so we got to complete each step. You can underline with your partner if you want to. So all of y'all should already be in groups of like 3, if not 2. If you're by yourself, please partner up or go to a table with somebody. But most of y'all should already have a partner, if not 3 people at a table. So before I even read step 1 and 2, this is how this is going to work. The people that are closest to the window, y'all will be partner A. If you're in the middle, like if you're a group of 3, you're going to be partner B. If there's nobody in the middle and it's just 2 of y'all, then partner B will be the person closest to the door. But in the group of 3, partner A is going to be close to the window, partner B is going to be in the middle, and then partner A is going to be closest to the door. So 2 people on the end will be partner A, person in the middle will be partner B. Okay? I just need a difference in the group. Y'all can just not be doing the same thing. All right? So let's read step 1. Step 1 says choose one. Okay, that's our action. A starting number from 1 to 100. You and your partner must choose the same number. All right, so you're choosing a number in your groups between 1 or from 1 to 100. I'm gonna tell you right now, nobody's allowed to choose number 1, because if you choose number 1, that's you being lazy. You gotta choose a number 2 and up. Okay. Take about 30 seconds. Go ahead, pause the video, figure out what number y'all gonna pick. Should not take you long. Go. All right, so now that y'all have chosen the number, please write that number. So write your number in the corner. The number that I'm going to pick is the number 3. Okay, so then I need y'all to follow step 2, which says apply the following operations in the given order. All right, so whoever's partner A is going to take y'all chosen number and follow partners A's direction. Whoever's partner B is going to take y'all chosen number and follow partner B's direction. So I'm going to give you like a minute and a half, 2 minutes to do that. Go ahead, pause the video, get started. All right, so we should have went through our processes. So I'll go through both processes as if I'm partner A and partner B. So if I was partner A, I would take my number, right, and multiply it by 3. So I know that 3, eraser. I know that 3 times 3 equals 9. All right, then it says add 2. So then 9 plus 2 equals 11. Then it says multiply by 4. I know that 11 times 4 equals 44. Then it says add 8. And then 44 plus 8 equals 52. Okay, so being partner A, so if I was partner A, I know that 52 was my number. All right, so now let me pretend like I'm partner B. So if I'm partner B, it says multiply start number by 2. All right, so I know that 3 times 2 equals 6. Then it says add 3. So then 6 plus 3 equals 9. Then it says multiply by 6. So then 9 times 6 equals 54. And then last thing, subtract 2. 54 minus 2 equals 52. So if I was partner B, I also got 52. So step 3 says compare ending numbers. What you guys should have seen working this thing out, you got ended with the same numbers. Okay? So this little activity is just an activity that kind of emulates how things work when we solve equations. What I mean by that is, you know how we do the same thing on both sides. So y'all aren't necessarily doing the same thing, right? But y'all are trying to get to the same end goal. So ideally, partner A would be side A of the equation, right? And partner B would be side B of the equation. And y'all picking a number is saying y'all picked a variable to see if doing side A's instructions and side B's instructions will get you the same answer. So, like, for example, if I was to write an equation, right, it just so happened that emulates what partner A was doing. So it says, like, multiply times 3. So that would be, without writing my number, like not knowing what it is, that would be 3x, right? Then it'd be plus 2. Then I gotta multiply that by 4. So then it'd be times 4. But the times 4 would have to happen after I add 2, right? So that means I would have to put this in parentheses. So then I don't need that dot there. I could just put the 4 on the outside. So 4, right? And then it says add 8, okay? So this would be what partner A's equation should look like if we were using it to solve the problem. And you can also do the same thing with partner B, just making sure that what has to happen first or before another action actually happens. All right. So now on the other side of the page, of page 149, we have that blank sheet. Get ready to write some notes over there because we have some notes that we need to write. Okay. So, all right. So the title of your notes is Identifying Numbers of Solutions, parentheses, answers, underline, for linear equations. So, like I said before in the beginning, we have been solving linear equations. A linear equation, just to remind you, is something like this, right? It's equal to, I could just put 5x, right? Or I could just put a number, or I could put an entire another set of directions, okay? But this entire thing is a linear equation, all right? Why is that? Because this over here is a linear expression. This over here is a linear expression. They're being said that they're equal, so in turn, they make a linear equation, all right? So now that we understand what linear equations are once again, let's talk about the answers for them, okay? So when you have a linear equation, you can have an option for, like, there's 3 type of linear equations you can have with your answers, okay? So you can have one that has one solution, okay? All of the linear equations we have solved so far have had one solution. The reason we know they have one solution is because when we get to the bottom, or like once we solve the equation, we get that x is equal to whatever number, okay? that number is the only number that we can put in for x to make the solution where you have the same number, like where they're actually equal. You have the same number on both sides. Okay, so that would be your first option for types of solutions. Okay, the second type of solutions that you can have is, and I want to make sure I spell this correctly, so hold on. It is, what is that? All right. Infinitely many solutions. Okay. So to think about this one in a nutshell, infinitely many solutions. If you think about infinity, infinity never ends, it keeps going. So if you have infinite many solutions, that means all answers you put in will work. So that means it doesn't matter what I put in for x, it's going to make it where they're equal. Through this lesson, I will show you why that is true, because I'm pretty sure some of y'all are looking confused, like that makes no sense. But there is ways to understand and see how this works. And then finally, the last one, the last type of solutions you can have when solving equations is no solution. Okay? So these are the three types of answers or solutions you can have when you're solving an equation. Solving a linear, go back, solving a linear equation. Either you can have one solution, like we have been having. You can have infinite many solutions, which means you have endless solutions, basically any and every number that you could put in there. Or you can have no solutions, where you don't have any option to put in there for the equation to be equal. Okay, so now let's go back to page 149 in the book to do part 2 of the table. Okay, back on page 149, number 2, it says consider the equations given in the table. Okay, so the action is to, the action is to consider the equations given in the table. All right, it says indicate, that's our verb, which value of w makes the equation true. Each equation true. Okay, so I can make this really simple for you guys, right? So with this table, what we're doing, they're giving us an answer for the variable for each equation. Okay, for equation A, B, C, and D. It's our job to go in and check and see if it works. If it does work, we will indicate that that number works for that equation. If it doesn't work, we'll leave it blank. Okay, or you can write an X. I don't care, either one. So write a check if it works, write an X if it doesn't, or just leave it blank and only write the ones that work. All right, so I'll do equation A, and then just like before, y'all have like at least 3 to 2 people at a table. So y'all will conquer and divide. So that means each person will get an equation to work out. It's not a hard process, and everybody has calculators on their desk. All right, so I'm doing equation A. So the first number I need to think about being W is 0. So if 0 is W, that means for equation A, I'm doing 8 times 0 plus 5 is equal to 5 times 0 plus 8. I know that 8 times 0 is 0 plus 5 equals, I know that 5 times 0 is 0 plus 8. I know that 0 plus 5 is 5. 0 plus 8 is 8. So this did not work because these are not equal. So 0 is not an option. I put an X there, or I could just leave it blank. Okay. That is basically what you're doing for all of the equations. You're just plugging in the answer to see if it works and marking if it works or not. Why did I put a check there? It's not a check. Next. All right, so now let me do 1. So if I do the number 1, That'd be 8 times 1 plus 5 is equal to 5 times 1 plus 8. Know that 8 times 1 is 8 plus 5. I know that 5 times 1 is 5 plus 8 equals 5. 8 plus 5 is 13. 5 plus 8 is 13. Does this one work? Yes, it does. So I'll put a check mark and go on to the next number. All right. So now the next number would be 2. So let's do it. 8 times 2 plus 5 equals 5 times 2 plus 8. Okay? 8 times 2 is 16 plus 5 equals 5 times 2 is 12 plus 8. I know that 16 plus 5 is 21. I know 12 plus 8 is 20. So this is not equal. So 2 did not work. All right. Okay. So then now I'll do number 3. 8 times 3 plus 5 equals 5 times 3 plus 8. Okay. 8 times 3 is 24 plus 5 equals 5 times 3, which is 15 plus 8. Okay. 24 plus 5 is 29. 15 plus 8 is 23. Once again, this does not work. They're not equal. Put an X. All right. So that is what you're doing. You're going through each number for your equation that you're doing, because remember, y'all are splitting this up and seeing if that number works for your equation. If the number does work, put a check. If the number doesn't work, either you can put an X or you can leave it blank. I don't care which one. Pause the video, figure out which equations y'all are doing. You only have, I'll give you like 5 minutes for this. Go ahead, start. All right, so we should have figured it out by now with our 5-minute timer. So I'm just gonna go through the answer choices. So for equation B, 0 did not work, 1 did not work, and 2 did not work, but 3 should have worked. All right, for equation C, 0 works, 1 works, 2 works, and 3 works. Okay, and then for equation D, 0 did not, hold on, I'm sorry, keep changing. 0 did not work, 1 did not work, 2 did work, and 3 did not work. Okay, so if we tally the results on the side, we know for equation 1, 1 is the only answer. If we know for equation B, 3 is the only answer. For equation C, 0, 1, 2, and 3 all work. And for equation D, 2 is the only answer. Okay, so now before we go to the next page, I want to connect something that I told y'all before with the notes. So remember, I told you there are 3 types of solutions you can have when you're solving equations. One solution, which is what we've been doing. Infinitely many solutions, which means you could go however far down the number line, negative numbers, whatever you put in is going to give you the equal on both sides and no solution. So if we look at equation 1 has only one solution. Equation A. Equation B also only has one solution. Equation D also only has one solution, but equation C works for all of these numbers. So it is a very strong possibility that equation C is one of the problems or an equation that could have infinite many solutions. So now I'll go to page 150 so we can work it out and I could explain to you why, how it looks, and what happens when you get infinite many solutions from solving an equation. All right. So now we should be on part B, okay, which it says solve equation. So you would box solve, because that's the verb, equation C. All right. So if we're solving equation C, so the first thing I'm going to do, I'm just going to rewrite it so I have space for y'all to see it. Okay. All right, we go through our steps as usual. Step one, parentheses. I do have parentheses. Let me see if I can solve what's on the inside. I cannot because it's a variable and a regular number. So now the only way to get rid of the parentheses is to distribute. Distributing this 3 to this 4w and to this plus 3. 3 times 4w would give me 12w. 3 times a positive 3 would give me a plus 9 equals 12w plus 9. All right, so now step 2, I do not have like terms on either side, so I cannot combine like terms. All right, then I go to step 3, but since I have 2 variables, remember, I'm at special step 3, which means I have to get rid of one of the variables. All right, in this situation, if you notice, it does not matter which variable I get rid of because they're both the same variable and they're both the same sign. So to get rid of them, I would have to do minus 12w no matter which one I got rid of. So what that's going to end up doing is canceling this out and canceling this out, saying that 9 is equal to 9. Okay? So I want y'all to digest what just happened for a second while I explain it, okay? So whenever you have an equation, a linear equation that you're solving, to know that it has infinite many solutions, right? When you solve it, what ends up happening is that the two variables end up canceling each other out, leaving you with the regular number or the constant, saying that this is equal to this. Like it shows you that you have the same amount on both sides, which means that any number you plug in for W will give you the same amount on both sides, okay? But that is not the only way that you can identify that it has infinite many solutions. So now what I'm about to show you is the shortcut for you to understand when something has infinite many solutions without doing the last part of getting rid of the variable, okay? Understand that if you get rid of the variable, you will end up with the same number on both sides, and that is what tells you, oh, I have infinite many solutions. But you can figure that out before you get here, okay? Let me show you how. So I'm going to erase this for a second, right? I'm going to go back to step 1. So I did step 1, right? I distribute. I get 12w plus 9. It might look like a T. I don't want to do it like a T. Plus 9 equals 12w plus 9. So, like I said before, I don't have to do step 2 because I don't have like terms. I'm at special step 3. So, when you are trying to identify whether you have one solution, infinite many solution, or no solutions, you have the opportunity to do that when you get to step 3. It does not matter if it's special step 3 or if it's regular step 3. You should be able to figure it out at step 3. So let me show you why. Specifically for infinite many solutions. When you have infinite many solutions, your variables, your coefficient in your variables will match. And I don't mean slightly match. I mean they will perfectly match. They will both be positive or both be negative, both be the same number, and both have the same variable. So as we see, it's both positive 12w, okay? And you know what else is going to match? Your extra number known as your constant will also be the same. So if it's a minus 5, it's going to have minus 5 on both sides. If it's a plus 5, it's going to have plus 5 on both sides. With this problem, it was plus 9. So let me break down what that means to you. You're basically looking at the same exact equation on the same each side. So of course it's going to be equal to each other. So how does that make it have infinite many solutions? Because whatever I put in for W here is going to be the same thing that I put in for W here. So whatever W does on this side is going to do on this side because it's the exact same thing. So once you see that everything matches in step 3, And I mean, it has to match perfectly. There can be no discrepancy. Everything needs to match. Then you know you have infinite many solutions. And you honestly don't have to do the rest of step 3 from there if they're asking you how many solutions it has, because it has endless solutions. So let me show you what I mean, because you should already know from part A, but let's just do it again for example, right? So if it's 12W plus 9 equals 12W plus 9. Let's say I say W is 2, right? I know that 12 times 2 is 24. 24 plus 9 will equal 24 plus 9. I don't need to add these up to know that they're going to equal the same thing. All right? I could switch the number, right? No matter. I could do -7. All right? -7. I know that 12 times -7 is -84. It's going to be -84 over here too. Plus 9. Plus 9. They're going to equal the same thing. It does not matter what number you use. They're going to equal the same thing. You can use any number, which is why it's called having infinite many solutions, because you have all the solutions, okay? But remember, you can only figure this out through the shortcut at step 3. It does not matter if it's special step 3 or if it's regular step 3, because you're checking to see if these equations on both sides perfectly match. If they perfectly match, you know you have infinite many solutions, because that means the variable can be whatever. It can be anything, okay? Now, let's move on to numbers 3, 4, 5, and 6, okay? So for numbers 3, 4, 5, and 6, it says determine, that's the verb, the number of solutions to the equation. All right, that's what I need to do. If the equation has only one solution, solve the equation and check your solution. So now, right, because like I said before, we've already been working with solving equations that only have one solution. But we've also now learned how to identify when an equation has infinite many solutions. So we're going to use this knowledge and these skills to tell whether each one has, okay? So I'll do number 3 and 4 with you, and then I'll let you do numbers 5 and 6, okay? So doing number 3, right? If I look at number 3, going through my steps, right? I don't have to do step 1 because there's no parentheses. I don't have to do step 2 because there's no like terms on either side. So the question is, I'm at step 3, right? So since I'm at step 3, I now have the opportunity to check, because I gave y'all the method, if it has infinite many solutions or not, okay? So if I look at this, I'm going to check my number, like my variable numbers first. So I have a plus 5 over here, and then I have a regular 5 over here, which is basically a plus 5. Okay, so those match. Then I have a minus 9 over here. I'm sorry, a negative 9 over here, and a minus 9 over here. Remember what I told y'all, minus 9 and negative 9 do the same thing. They are the same thing. So guess what that means? Number 3, I don't have to do any work because they have the same thing on both sides. So it has infinitely many solutions. Which means, if you want to test it out yourself, you can plug in any number for x, and it's going to make it where you get the same value on both sides. Okay? Very simple, right? So now let's go to number 4, where it could be a little bit more complicated, right? Because we got a little bit more work to do. So we got to solve the equation first, or start solving it. We got to at least get to step 3, okay? So is there step 1? Yes, there is. Can't do what's in the parentheses. Got to distribute. So if I distribute the 3, that gives me 9v plus 1 is equal to, all of this stays the same, 1 plus 6v. Okay? All right. This actually, I'm going to rewrite it because I don't want y'all to get confused with what you're seeing. So it's 1 plus 6v equals 9v plus That should be a 3, not 1. I'm sorry for saying 1. That should have been a 3 because 3 times 1 is 3. All right, so if I check, because I don't have to do step 2 because I don't have like terms on both sides. If I check to see if the variable numbers match, they don't. Okay, and the regular numbers don't match either. So I have to keep solving this to see if I have one solution or not. But I'm at special step 3, which means I have to get rid of the variable that will give me the positive value. So I would get rid of the 6, because if I take 6 away from 9, that would give me a positive 3 versus me taking away 9 away from 6 to get a negative 3. This is still here, so that's plus 3 equals 1 because 1 is still over here. This goes away. All right, so now I need to start getting the variable by itself. So that means I would subtract 3 from the plus 3 to get this gone, and that's 3v. 1 minus 3 would be a negative 2. Okay, then I need to divide by 3. So that means v would equal negative 2/3. Okay, so this is, since I got this as an answer, which is what you should be used to finding the one variable, that means that this problem I can identify now only has one solution, but I still need to do the other part of the problem because I've solved it. Now that knowing that it has one solution, I need to check my work. So I need to take this negative 2/3 and put it in the original equation to solve it. To see if it works. All right. So if I put in the original equation, I'm gonna just write over here. That way I have space. That's 1 plus 6 times. Actually, I'll write it as a fraction. So 6 over 1 times negative 2/3 equals 3 over 1, since I'm doing a fraction. Negative 2/3 plus 1 over 1. Okay. So, wait. Let me go back because I left something out. I'm gonna write this regular. So 3, and then the 3 is on the inside. 3 over 1 times negative 2/3 plus 1. There you go. All right. So now I would do parentheses first. So I know in here this would equal negative 6 over 3, which is going to be able to be reduced to turn into negative 2. So this would turn into negative 2 plus 1 times 3. All right. I hate that I write it and it looks like an H. Plus 1. All right. Negative 2 plus 1 would give me 1. Negative 1 times 3. So now let me get this side caught up. Over here, I would I'll multiply. So then that would end up being negative 6 over 3 again. Okay. So I know that equals negative 2, right? So then I have negative 2. Oh, no, actually, I did that math wrong. I did that math so wrong. So this equals 12, negative 12 over 3, which would give us negative 4. Okay. So negative 4 plus 1 is what's over here. It would be brought down again after you do that math. So then if we finally work it out at the end, negative 4 plus 1 would give me negative 3. And then negative 3 times negative 1 would give me negative 3, which means that this is the correct answer for my problem. Okay, but just like before, where I showed y'all a shortcut of how to identify if something has infinite many solutions, there's a shortcut to identify if something has one solution. Okay, so once again, I'm gonna go back to the original equation and I'm gonna do step one again. So I do step one, we remember that this side stays the same. Then we get 9v plus 3. Okay, so we know we can't do step two, so we get to special step three. So once again, when you get to step three, so if we haven't noticed by now, when we get to step three is the point where we can start identifying if we have one solution, infinite many solutions, or no solutions. All right, I'm gonna say that again. Very important hint. At the third step, it does not matter if it's a special third step or the regular third step. Most of the time, it's probably going to be the special third step. That's when you can identify through a shortcut, because I'm showing you what the shortcut is now, if a equation has one solution, infinite many solutions, or no solutions. Okay? So just like before, when we checked for infinite many solutions, the first thing you check is your number with the variables. They do not match in this situation. So guess what? That's all you need to know that you have one solution. Okay? So I'm going to compare it to what we looked at when we had infinite many solutions. Remember when we had infinite many solutions, they matched. Okay? But not only did that match, the back number matched too. But with one solution, once you see that these don't match, you know you're going to have one solution, because let's think about what happened with infinite many solutions that made us be able to say this. Okay, since the variables were the same, right, when we were solving it, we ended up getting rid of both variables no matter which variable we tried to get rid of. But when you have one solution, because the variables are different, you're always going to end up left with a variable that you can find the answer to. Okay? That's literally what makes it one versus many. Okay? So now on the next page, go ahead, pause the video. I want you guys to try to do numbers 5 and 6. I'll give you like another, I'd say about 5 to 7 minutes for that. Depends on how long it takes. Shoot for 5. Go ahead, pause the video. Start now. Okay, so we should have done numbers 5 and 6. So let's go through them real quickly. So if we look at each side, or if we look at number 5, right? Number 5 has it where we have fractions. Okay, so it is very possible for you to use the technique that we did in the lesson before this, lesson 8. So if you use that technique, this is your opportunity to check and see if you did it right. Okay, so going through my steps, I can't do step 1 because there's no parentheses, but I can do step 2. These are like terms over here because I have 2 W's, and then I have like terms with this 6 and this -4. Okay, so now that I've identified the like terms, remember you interact them from left to right. All right, so on this side, that would be a positive 2/5 W minus W. So in order to subtract those, right, because it's 2 fractions, I know that there's a 1 imaginarily in front of that negative W, so that's a negative 1 W. So I would just turn it into a -5/5. So then that's me subtracting 5/5 from 2. That's me subtracting 5 from 2, which would give me a -3/5 W. Okay, then I still have +2 over here is equal to, so since I'm not doing nothing with the variable because it's only itself, I could already write 3/5 W, and then I would do 6 minus 4. What is 6 minus 4? That would be 2, so that would be a plus 2. So now I'm at special step 3, but what should I notice about my equation to help me answer the instructions? I should notice what? That my variable numbers, also known as linear terms, so the coefficient and the variable when they're together is known as a linear term, okay? So I noticed that my linear terms match, and then my constant or my regular numbers match. So that means this problem has what? Infinitely, spelling it wrong, many solutions. Okay? No more work to do. Moves on to the next problem. So for the next problem, I need to solve it once again. Doing step 1, I have to do step 1 here. So that's negative 4 times both of these. And then over here, that'd be 6 times both of these. So negative 4 times 3a would be negative 12a. Then negative 4 times negative 6 would be a plus 24, okay? Equals 6 times 4 is 24 positive. Then 6 times a negative 2a would equal a negative 12a. All right, so now I can't do step 2 because I don't have like terms on either side with each other. So I'm at special step 3. If I look at special step 3, let's see if the variables or if the coefficients match, okay? So if I look here, I have negative 12a on both sides. And then if I look here, I have a positive 24 on both sides. So once again, what does that mean? That means that these two problems have infinitely many solutions. No more work to do, okay? Does that make sense? It should very much so make sense. What you really need to practice doing for this topic is like how to identify from step 3 whether it has infinite many or one solution right now. We're not going to talk about no solution until we go to lesson 10. So focus on infinite many and one, because those are pretty easy. It's pretty distinct. Make sure you write down or make a note of my hint so that way you know it. And then I'll let you guys do number 7 as a practice problem in class. And I'll just look at it and go over it when I come back. But I will go through the instructions with you. So it says consider the equations. So you have group A and group B, right? Okay. They look like they solved, or they have a bunch of equations that they are solving. All right. It says describe the characteristics of the equations in group A, and then describe the characteristics of the equations in group B. So this problem should help you with the identifying part, which is the part I told you to work on. So go ahead and do that. After you do that, you have homework or classwork to do, which would be on your agenda. It would be pages 157 through 159. I'm not exactly sure of the numbers right now, so please go check your agenda and get the numbers off.